What's missing from folic acid is a methyl group. And to put that methyl group onto folic acid requires multiple steps. In fact, I'm looking at a pathway here on my nerdy poster that I drew out. And there's 1, 2, 3, 4, 5, 6 enzymes. And enzymes are produced from genes. There's 6 enzymes that are required to transform synthetic folic acid into the body's number 1 primary form of folate, which is called methylfolate. So folic acid isn't methylated. The body's primary form of folate is methylfolate. To put that methyl group onto folic acid requires 7 different enzymes, and a lot of those happen to be difficult to put that methyl group on there because they're not working quite right because of genetic variations from our ancestors for various reasons.
So, yeah, maybe this is a great time to jump in, and you did present, I'll actually include it in the show notes here, that wonderful biochemical pathways so we can get a sense of those enzymes. But perhaps maybe a great time to talk about SNPs and what some of those defects are in those pathways that people might have.
Yeah. So, when I first looked into SNPs, like MTHFR was my first one, and you read the research about how it's associated with all these conditions, negative conditions, right? Preeclampsia, infertility, breast cancer, you immediately associate MTHFR SNPs as bad. And first of all, we have to define a SNP. And a SNP is genes are made up of long amounts of basically DNA bases, right? So there's these bases of amino acids, and thymine, adenine, guanosine, so on, cytosine, and they're linked together. And as they're linked together in various organized fashion, they produce the gene. And so some genes can be thousands of these long, some of them can be tens of thousands long. And when one of those base changes are different, that's called a SNP, a single nucleotide polymorphism. So those bases, those amino acid bases, are called nucleotides. And so when one of them switch, it can alter the function. Now, we have to keep in mind that these SNPs can be deleterious. I'm just going to say bad.
Yeah, for sure.
That's a hard word for me to say. So they can just not be beneficial to us at first look, right? They've altered their function. They've either sped it up or slowed it down. And so a SNP is different than, well, let me back up for a second. Genes can be very, very common in the population. A certain gene like MTHFR, the majority of the people have a MTHFR gene that has a cytosine nucleotide. However, 50% of Italians and Mexicans and the Chinese have that cytosine nucleotide switched to a thymine. And that thymine is where that problem happens, that shift. So it's just that one nucleotide that shifted from a cytosine to a thymidine, and that's causing all this hoopla about MTHFR. And yeah, I got on the bandwagon, and it's that what it did is it altered its function by about 30% or so. It slowed it down. It didn't make as much methylfolate. And so that's what SNPs can do. They alter the speeds of genes.
Gotcha. So like someone